This Hangout is live. Okay. Good evening, Year 11. I'm going to be spending the next, hopefully less than 1 hour, going through your Year 11 mock exam paper. I currently have 4 viewers, which is outstanding. That's funny. 6 viewers. It's climbing. I like it. I'm going to start it in 7 viewers. I'm going to start it in 3 more minutes. So obviously I'll just give you a quick chat for 3 minutes while we wait for as many viewers as possible. I mean, obviously we should have 60 viewers at least for the entire of Year 11, but I'm sure everyone's having a lovely time on their holidays. Now I've got 8 viewers. Oh, I'm now back. I think I've just believed. I have no idea whether or not. I wonder whether I can improve the quality. Oh, look at this. My lovely assistant, Donna, is going to be helping me with the live feed today. She's going to be reading out your questions to me that you have.
Nobody can see me, can they?
No, no one can see you, sweetheart. 7 viewers, back to 8 viewers. The 2 viewers which I managed to make disappear before have come back. I like it. Now, what I have done, 10 viewers, outstanding. And by the way, I will be trying to figure out whether or not I can improve the video in terms of quality-wise. It would be good if I can make it as good as possible so you guys can see what I've done in terms of your questions. I have done your exam paper as well and filled it out with model answers. So you'll be able to add any of those answers to your own papers. You should all be sitting there with your papers in front of you. That's the hope. And that way you'll be able to write in that green pen for all those corrections that you'll be wanting to make. I've now got 14 viewers. We're doing really, really well. There is a chat. I mean, I'm a novice at this, so what I'm just going to quickly do is add a message onto the chat window, which will be, "Hi everybody," and what I'd love your help doing is just to check that everyone can hear me. I've muted my other computer, and so I'd love to have some of you guys dropping and hear me okay, and see me okay. Viewers. Still have no messages. If you press on the video window, and then there's a little chat thing in the top left-hand corner that you'll be able to bring down. It's like a chat bar on the right-hand side. Give that a go. I'm going to get my other half to see if you can click on that and see if you can add your message. I just need to make sure that you can all hear me. It would be embarrassing if you can't. There we go. So there's me. Can you hear me? So you can message on the chat. We now have 13 viewers. Can you all hear me? I hope so. Or just to say that you can hear me. This is always very entertaining. I apologize for the lateness of the video, 7 o'clock at night. It won't take us very long to go through it, I don't think. Do we have any chats from anybody? No. Oh, where are my chats? Come on, everybody. "15 viewers, still no chats. If I don't get a message from anybody, then I can't answer your questions. List all available commands. Toby Duncan has joined group chat. He probably just said that. I'm going to see if I can post an emoji. There we go. Let's lob on an emoji. Let's see if that works. Oh, there you go. There's an emoji from me. Still nobody messaged. Okay, it's 1 minute past 7. I'm making this great. I really hope that everyone can hear me. Don't seem to have anybody on the chat just yet, which is sad. But we can proceed. Right, what I'm going to do, I'm going to share my screen with all you guys. It does a rather funny thing. Yeah, there we go, which is rather interesting. And then hopefully, there we go. Your paper has appeared. Okay, so starting at question 1. Any chats yet? Nope. Still no chat. So I really hope everyone can hear me okay. And I haven't muted something I shouldn't have. Shouldn't have. Okay, so now what I'm going to try and do is highlight those questions. I can also show the data as well for each question. But just to go through, question number 1 was a nice, easy start to the paper. Some nice little niche bits to this question, which was quite interesting. So, name the central part of the atom. Most people got the nucleus, which is great. However, there were some interesting answers of people putting nuclei. Now, nuclei is not the right answer. The reason why is that the nuclei, a nuclei is it's a name given to protons and neutrons. So nucleus was the right answer. It had a good high percentage. You'll see it okay? Yeah, it looks all good. Name the positively charged particle in an atom. Nice and easy. Proton. It was all good. State how the diagram shows that this atom is neutral. First, tricky question. I wouldn't even say tricky, just there were a couple of people who didn't quite get this and named the wrong pieces. And you had to say that there were equal number of protons and electrons. Of course, lots of people said well, a few people put equal numbers of protons and neutrons, but of course, the neutrons being neutral makes no difference to the overall charge. A better answer to that question, and considering it's my model answer, it's nice for us to be able to actually count them. So we have got there, you can clearly see that there is 3 protons in the center and 3 electrons going around the outside. So it's nice that if you can actually quote those numbers and any questions like that, it's always good. If that was 2 marks, it would definitely have wanted those numbers. First question that students found tricky, and there was a reasonable number of students getting it wrong. The mass number of this atom. Now, lots of students, of course, realized that this was lithium before they got to this question, which for me is lovely. Clearly shows that you guys had the periodic table sitting next to you in your mock exam, and you were looking at it and you knew how to identify that atom. So you knew that there were 3 protons in the core, and you looked up the atomic number and saw that there was 3 protons, it was going to be lithium. And then unfortunately, a couple of people then quoted the mass number straight off the periodic table, and they quoted it as 7. And of course, for this one, it's not. They've given us an isotope. We've got 3 protons and 2 neutrons in that nucleus. So this is actually an isotope of lithium. So you had to ignore the electrons, realize that the mass number comes from our particles in the core. And that's, so in terms of picture-wise, it's the protons and neutrons in the center that added up to 5. Next question. Give the name of the element. And again, well answered, lithium being the correct answer. Okay, question number 2. So this dropped you into a displacement reaction. We're adding metals to copper sulfate. And you can see that I've circled something because it asked you to state 2 variables which must be controlled. And a lot of students put the mass of metal. Now, that's unfortunately the wrong answer. And the reason being is my circle bit. He repeats the method using the same amount in moles of different metals. What that means is they're ruling out keeping the masses the same. Because if you keep the masses the same, due to elements having different weights, different atomic masses, then you're going to have different, there would inherently be different masses of metals due to them all having the same number of moles. If that's not clear, I can give an example of this. If you had 1 mole of aluminium having a mass of 27, that would be in grams, 27 grams. If you did the same thing, if you wanted 27 moles of something else, the mass would be different. So the 2 variables they wanted you to keep the same: concentration of the copper sulfate solution. They also allowed the volume of the copper sulfate solution. I personally don't, that is absolutely correct. It's a good answer. The reason being is if you have a different volume of fluid, then the temperature rise would be, well, if you've got a smaller amount, it'll be a higher raise. If you've got a larger amount, it would be a smaller increase in temperature. So volume or concentration of the copper sulfate was good. The other one was the surface area of the metal. It's nice to actually say that these questions come up on a regular basis. Surface area is one of the most difficult ones to actually maintain, of course. And so, of course, they could ask, well, how would you actually do this? And in that case, it would steer you away from the surface area answer and steer you towards the volume using a measuring cylinder. But those 3 answers were the top answers for that off the mark scheme. Next one. A few people left this question entirely blank. I think they just didn't realize I had to fill it in. And the key thing here is I have circled 5.5. And this is because the 5.5 for H was an anomaly. So for G, now a lot of people are going to be frustrated with this question. They're going to be saying, how do I know what an anomaly is? How far a deviation do I need? Because a lot of people calculated G and they ignored repeat number 2 at 5. That's not correct. If you look at E, and they'd done the average for you, and they can clearly see that they included, they discounted the 4 as an anomaly. And they'd only added together the 7 and 8 and divided by 2. So you had to realize that the 4 was far enough away to discount. So you should be definitely discounting the 5 from the 11 and 12, but not to discount the 5 in G on repeat number 2. So the average for G was 5.5. The average for H with your discounted anomaly was 11.5. Can I also say at this point, I know that maths is very, very basic. But there were an awful lot of students who did this maths in their head and didn't bother with the calculator and gave me the wrong answer. So please, 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 if you're given even a simple maths question in any paper, please make sure you're using your calculator. Don't throw away 3 marks just because you look at it and go, I can do that in my head. Just watch out for it. Okay, next, explain which metal is the most reactive. Now, a lot of students went for E instead of H. The reason being is they'd calculated their average from H, and I don't know why it had just made them just completely ignore it. So anyway, so the answer was H and of course they ask you to explain your answer. A few students just wrote H and walked away. Didn't realize that the second mark was for the explanation. You need to say that it showed the greatest temperature increase. Which is less reactive than copper? Oh, we're on the live chat, but you can't see us. Oh, Donna, thank you for sending me an email. We're on the live chat, but you can't see us. Yes, that's correct. I think I'm Donna. I muted your videos. I muted your video. That sounds really mean, doesn't it? I muted your oh, I've gone crazy. I muted your videos because I figured that you definitely don't want me having a million videos, image websites, windows open with all your faces on, because I'm sharing my screen. So I figured it was just easier to do it that way. Donna, thank you so much for sending me an email. Can you send me another email that just says, can you hear me okay? And is the quality of the video all right? I don't quite understand why the chat window isn't working. No one seems to be using the chat, and I don't know why. But if you can send me an email, Donna, just telling me that you can, I'd really, really appreciate it. Okay, anyway, going back to F. F is less reactive. Now, the mark scheme was really generous on this because you were simply allowed to say that there was no reaction. Now, I just a warning on that I've seen that question in the past where they've actually said specifically on the mark scheme, do not allow, because there was no reaction. The reason why we know it was less reactive from the data was because there was no temperature change. So do be aware of that. And you can see my answer. I put both. When I was doing this, I didn't have the mark scheme in front of me, and I wanted you to see the kind of answers that I was writing as if I'd been sitting in an exam situation myself. So I actually wrote F is less reactive, no temperature change, so no reaction. I wanted to make it as clear as possible to the person marking the paper that I knew what I was talking about, and I was using the data specifically from that. Okay, let's go for the next one. Right, first one, which really students found quite difficult, and it was all about the explanations. So it said, looking at the following boxes, 6 boxes, which 2 are elements? So which 2 elements, of course, was box number 1 and box number 2. Now, what I loved about this question was it was rather nice because they wanted you to be giving the definition of an element. So they wanted you to say all atoms in the boxes are the same. Box 1, only helium atoms. Box 2, only hydrogen atoms. You didn't even need to comment on whether or not they were bonded. You just simply needed to state what was in the box and the fact that they all were the same atoms. That was the key to that one. Oh, no, hang on. I've just got an email off Dana. We can hear you and see you, but you can't see us. Ha ha. Love it. Thanks, Dana. You're a star. Right, that makes me feel a whole lot better. It means I'm not saying this and looking like a complete idiot, as like I'm miming the whole thing. Okay, explain which 2 boxes represented mixtures. This one was the first question, which was really students struggled to answer. And again, it was a similar kind of setup, but this time it was trying to explain what a mixture was, and that's quite difficult in itself. So boxes 3 and 5 are our mixtures. Box 4 is pure water, and box 6 is pure hydrogen peroxide. But box 3 and 4 are both, box 3 and 5 are both mixtures. And you'll notice what I said. I said box 3 contains helium mixed with hydrogen, and box 5 contains water and hydrogen. Yes, I put and hydrogen because I missed the D there. But you simply had to state what was in the box. So you were actually, there were a whole load of extra things on the mark scheme. It said you were allowed to say for box 5 that it contained 1 element and a compound. For box 3, you were allowed to say it contained the noble gas helium as an atom and hydrogen gas as diatomic. It allowed you to do all these kind of ways to help you give options for being able to describe what was in the box. These questions do appear a lot, so do make sure that you've had a bit of a practice at doing those, and I can happily post some more. I'll create a whole cohort Year 11 Google Classroom where I can post a few more of those questions if people want them. Next one. Okay. Separating water from sodium chloride solution. Distillation. That's a nice one. Just to tell you, by the way, if you're going to do that properly, you'd be using fractional distillation because it would produce much purer water. But distillation was the right answer. Oh, Winkit. Winkit is, I see you. I see that you have a Hangout open. Do you think we should all join the chat / ask questions? Yes, I'd love you to, Winkit. Definitely. Join the chat. That way, it shouldn't be too difficult. I don't actually know how. There obviously must be a difficulty here in joining the chat. But yes, I'd love you to. It'd be really useful because you can spit out your questions then as we go along, which really is what I wanted. Separating blue dye from the mixture of red and blue dyes was chromatography. And the last one, which was the one that I think a lot of students struggled with, was separating potassium nitrate from a potassium nitrate solution. And they wanted crystallization. We know that the method we use, another name for it is evaporation, but Edexcel much prefer the term crystallization for that process. So it's nice to emphasize that. And it's nice to also see that they're giving a multiple choice on that particular one. We're on the live chat, but you can't say, oh, the quality is very good. People want to ask you questions through the chat, through the YouTube chat. Oh, through the YouTube chat. I wonder whether or not I can find the YouTube chat. Ah.
Oh, you've gone on Google Hangouts.
Yeah, that's what this is. That's what's happening here. I have absolutely no idea how to find. No, don't click. No, yeah, click sign in. Right, okay. We will endeavor to. You're absolutely right. People are going to be asking on the YouTube chat rather than the Google Hangouts chat. We will do our best to endeavor to get this remedied, and as soon as we manage to find it, event. The problem is the live events will be lost in the procedure. Okay. I think this is going to be interesting. Click on my picture there, and then go to the YouTube chat beat, the Yes Studio, yeah, and then go to. Hang on, guys, just give me 2 minutes. We'll see if we can get this sorted. And then go to Creator Studio Classic. Thanks for trying, Skip. We're nearly there, nearly there. Dashboard, video live events. Come on, come on. Events. There should be one review. Google Hangout on air. Oh, I think we might have just. Hey, we're there, guys. We've got the chat window up. Okay. They think you're a bot. That's like 5 different. Yeah, do you want to type something in? We're on. We've managed to get the chat up. I've managed to figure it out. Got the second laptop running. Oh, does he see us? No, I don't, Mo. Don't worry. We don't. I think so. No, I don't see you. Hi, he's here now. Hi. This is great. Yes, finally. Okay, cool. So I've got my lovely assistant. Hi, Mr. Duncan. Hi, Tiffany. Thanks for coming. 5 different something between my. Yeah, okay. So cool. It's up and running. This is fantastic. I like it. Chat's been on. Good day. Okay. Right. So let's have a quick look. So next question, number 4. This question is about group 1 of the periodic table and their reactions with water. State-wise, sodium and potassium are in group 1. Nice and easy. They have 1 electron in their outer shell. We've seen these questions half a dozen times, so we know they're there. Next one, a reaction occurs when a small piece of sodium is added to a large volume of water. Give 2 observations. Guys, there were dozens of answers that you could have given for this. You could have said it fizzed, effervescence. You're not allowed to put gas produced because you can't see the gas. You have to say bubbles, fizzing, effervescence. Any of those words are good, but just don't put gas was produced. You could have said it floats. You could have said that it moves around. It skips around on the water. I loved that answer from some of you guys on your papers, skipping around. I thought that was rather entertaining.
Somebody's on the free Wi-Fi mall.
I love the fact that Johan is on the free mall Wi-Fi. Love it. Oh, look at that. Quayshan's in Japan. Loving this. This is brilliant. That's ace. Love that. Someone's in Dubai. Right. So you could have said floats. By the way, this is the important one for sodium. You weren't allowed to say that it caught fire. Now, this one, as a chemist, is a little bit irritating because every now and again it does. If you put a large enough piece in, it will catch fire.
Winkett says, quick question for the first question.
Oh, yeah. Go on, Winkett. What's your question for the very first one? I put fizzing, bubbling, Dinesh. Yeah, that's okay. Yeah, but I bet you put fizzing and then bubbling in the next one, didn't you, Dinesh? Did you do that? Having the same thermometer as a variable. Ah, great question. You're not allowed to put the same thermometer And again, as a practical chemist, I'd probably say you should use the same thermometer. However, pieces of equipment like that are deemed as, they're meant to all be the same. So that's one that's not allowed, because it's deemed as, if you use one thermometer, as long as it read 25 on both of them at the same time, you'll get the same temperature change. So they wanted you to be saying concentration. It's Winkit, it's exactly the same as saying use the same beaker. It's the same thing. I know it's not true. I know that if you use a different thermometer, some of the thermometers are terrible. But they want you to be going away from the equipment and into actual practical things like the solution's concentration and its volume.
Is time not acceptable for question 2?
No. Great question. Time for question number 2. Let's have a quick look.
Oh, the same question as Winkit.
Yeah, same one. I like it. Same time. Let's have a quick look. To make the experiment, he did the copper, so he added the metal the same temperature. You don't even have to do the same temperature, of course, because you're measuring the temperature rise. Yes, potentially. Maybe for the same amount of time, probably would have been allowed. I wonder whether or not that was probably not it. I would have given it if it was on the mark scheme. Yes, I'd agree with you there. Interesting. I wonder if somebody has put that and I didn't give them the mark.
It's not an answer because
yes, I know it says max temp. Absolutely. So yeah, so I guess the time would make very little difference to the max temp, but you can argue that, but I won't. But it's a reasonable response, and thanks for the extra info there. That was quite nice. That. Any other questions regarding the ones I've done? Okay, let's go back to this. So back to question 4. So loads of observations, but I do need to point out for sodium, because they've stated in the question a small piece, they're removing your ability. I wonder if this is going to let me write on it whilst I'm doing it. There we go. So because they've said a small piece, I wonder if that's going to appear on it. Same. Is intensity of stirring a good one? No. Do you know why, Dana? The reason why intensity of stirring isn't a good answer is because it's very difficult to control. It's, in fact, borderline impossible to do. Because what would you do? You'd have to make sure that you're stirring it at the same amount of rotations per second. You'd have to count them. It's just impossible. So no, not on stirring. Too difficult. Back to question 4. Just to confirm, when is paper 2 is tomorrow, Dinesh. Yeah. Okay. So back to question 4 again. I know, by the way, I'm sorry because we didn't realize that the chat was happening on the YouTube bit. It means we're having to go back through questions, and I apologize for that. We'll be slicker on the next one. Yeah. So because it had the small piece, they weren't allowing yellow flame. But there were lots of, you were allowed to say it became molten, it became a ball, it disappeared at the end. So loads of different answers. Please make sure that you don't put fizzing as 1 and effervescence as number 2. They are the same thing. I've just put it on my exam just because I wanted to be thorough and to include it. I think I might have even spelt it wrong. Anyway, so on to the next one. After the reaction has finished, again, this one really does need clarification, and it's not your fault, Year 11. It says, after the reaction has finished, a few drops of universal indicator were added to the solution, to the trough. Explain the final color. You had to state purple. Now, that was a problem because the universal indicator that we have in school is rubbish, and it's actually gone off. What that means is it doesn't turn purple anymore. It only goes blue. And a load of people have seen the teacher do this and have remembered blue. And blue is not allowed. It specifically says on the mark scheme, do not allow blue. You needed purple. And then the explanation was because you're forming sodium hydroxide, which is an alkali. Lots of students said because the metal itself. So lots of students put the metal is alkali. That's not allowed. Metals aren't alkalis. They're only alkalis once they react with water and form their alkaline solutions. So watch out for that little tiny detail. Please be careful. Yeah, so the metals themselves aren't. It's the solutions they form afterwards because they're hydroxides. Yeah. Question, I got the mark. but is hydroxide ions present a mark scheme approved answer? Absolutely, it is a mark scheme approved answer. Yes, it is. If you just had to say it forms hydroxide ions in the solution, which is why it turns purple, totally allowed. Why is blue wrong? The reason being is because it should never turn blue. Blue suggests a pH of around about 8 to 9, and the answer is purple. Purple for universal indicator is pHs of 12 and above, and so you had to give purple. Next one, of course, the blue then had this rather interesting, because people have picked up blue from the teacher's demonstrations, it then had a knock-on effect to the next question. What is the most likely pH of the solution? Lots of people who put blue put 8. And of course, it's definitely not. It's pH 12. I mean, in reality, you're going to actually be hitting pH 14. So a lot of students might then be like a bit annoyed that there was no choice of 14 there. But the answer was 12. You went for the highest one possible. This question made me giggle. What if I said OH minus ions formed because of sodium hydroxide production? Would I gain a mark? Absolutely. Yes, you would. Absolutely. Sure. That's absolutely correct. That's great chemistry. Great chemistry. This question made me giggle. Name the group 1 metal that is less reactive than sodium. I had some hilarious answers. People choosing cesium. Loads of people went for potassium. I don't quite know how they did that. You had to move up the group rather than down it. So loads of people picked the one below, and it was meant to be lithium. Next, a small piece of potassium is added to the large volume of water. Give one observation made, which is the potassium that is not made when sodium is. So this one was, you'll see a lilac flame. You can also say, but you're going to need really good descriptions here. You're allowed to say fizzes more violently. That's allowed, but it was the more violently that gains you the mark, not the fizzing. And I don't like it. You'll notice that I put the flame answer because I wanted to pick one that's very different. I don't want to have to persuade the marker that I know what I'm doing. I want him to give me it with absolute surety, so I chose one which is very standout. Hence why I quoted the color. Yes, that's correct. Metals can't be alkalis. An alkali requires you to have OH minus ions in a solution, and it must be in water. So I know that they're called alkaline metals because when they go into water, they form alkaline solutions. Just be careful with it. A metal itself isn't alkaline. No OH minuses, just a metal. So I went for the flame answer for the potassium. You're allowed to say skips around more quickly. You can say vanishes more quickly. Anything that had a difference, but they wanted you. I'm trying to push you here towards this flame, because that way there's no doubts and there's no, it means the marker doesn't have to think about what they're doing, and you want them to have an easy time. Next, balancing the equation just as it is there, 2, 2, 2, and of course an invisible 1. Lots of people put 1 in there. That is totally fine. I'd never, of course, do it on an equation because a 1 is just blank, but you're allowed to put it there if you want to. You are also allowed multiples. So I had a couple of people with 4, 4, 4, 2. Totally allowed. It is correctly balanced. So if you had that, you can gain it. Try to do the simplest if you can. You will also, by the way, you are also allowed blank, 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 half. Now, of course, we steer you away from halves at GCSE and stick to whole numbers because it makes the ratios easier. So 2, 2, 2, 1 is what they wanted. Okay, next. Question number 5. Okay, the worst question on the paper. And year 11, this is not your fault. This was something we went in year 9 when you pick up doing distillation. You're often taught about fractional distillation, and some teachers ask you to do a research task. Some teachers hope that students will do a bit of reading around the subject, because I teach the fractional distillation of crude oil as a separation that you need to know. Now this 5 marks, obviously everyone did badly. Don't worry about it. It's coming up in the crude oil topic in organics at the end of the year. So this question, I know it's impacted your final results because it means that you have a lower percentage, but please don't worry about it. Now you can see my answer. It asked you to describe how the diesel fraction is obtained from crude oil in step 1. So they simply saying crude oil to diesel. How do they do it? So they wanted to do this process. Crude oil is vaporized. The entire black liquid is vaporized into gas. It's does that say feed oil vapor? Yes, it does. That's correct. We're going to feed oil vapor into fractional tower. Yes, feed. Put in if you prefer. I like feed though. Crude oil is vaporized. We feed that gas into the tower. And that is a mark, amazingly. Because we vaporize the oil outside the tower. We feed it in as a gas. The tower has a temperature gradient. It's hot at the bottom, 450 degrees Celsius. You don't need to quote it, but it's nice to know. And it's warm at the top. You are not allowed to put that it's cold at the top. You have to stay warm. The vapor rises up the tower. Bigger molecules have higher boiling points. Diesel will rise up the tower until it reaches its boiling point, condense, and run out of the tower as a liquid. Is he doing this in school? No, I'm not, Dinesh. I'm sitting currently in my living room at my that's not asking my living room. I'm on my dining room table. I'm not going to sit in school at 7 o'clock at night. That would be crazy. Do you get bonus marks / pity marks if you drew a diagram for the fractionating tower? Love it. Sure, you can have a pity mark. I won't add it to the mark scheme. I won't add it to the mark sheet, but it's funny. Sure, you can have a pity mark. Okay, so I hope that makes a bit more sense. You're going to revisit this, guys, so don't worry. When I saw the question on the paper, of course, I knew that everyone was going to be finding that one difficult. There were some students who managed to get 4 marks on this question. So well done to those students who clearly been doing good reading around the subject. I was really, really impressed by that. My year 11s, I think there were only a few of you who got 1 or 2 marks. But tricky question. It's a story that needs learning, and we'll come across that in the next when we get to organics. Do you get marks for saying about fractional distillation? No, you don't. You have to actually describe the whole process in its entirety. The simple words of fractional distillation don't get you anything. You can see how I've broken it down, and you can see this structure. I've actually got 1, 2, 3, 4, 5, 6, 7 bullet points on that for 5 marks. I know that in those 7 bullet points are all my 5, but I'm never 100% sure which ones they don't need. So you have to quote the story in its entirety. And you'll notice there isn't a single one of those bullet points that actually says fractional distillation in it, because actually it's the description of the entire process that gets you the mark, which is frustrating. I know. I apologize for that. Okay, let's move on. Okay, so this question, okay. You guys found this question tough. And first thing was reading the gas syringes. Now, they gave you the starting one, and they gave you the starting one at 76. So it actually, it was nice because it was helping you realize you had to read it from 0 up. So you can see they go 60, then we went to 70, and then each little gap is 2. So it gave us 76, and the reading on the next syringe. Now this was actually really, really tricky, because if you actually look at the diagram, the line wasn't printed very well. And they allowed 2 answers on the mark scheme due to printing. They allowed you to quote 34, and look, I'm just going to highlight that. 34, in fact, I don't even want to do, I want to do it with an arrow. Yeah, that's what I'm reading right there. Actually, that was not very well done, to be fair. Let's see if I can make that a little bit better. I'm reading it here. And they allowed 34 was the top answer. It's what they wanted off the mark scheme, but they also allowed 35. So it was tricky that because the print wasn't clear. Some people even went, but it did, however, state on the mark scheme that you weren't allowed to quote a half, which I thought was quite interesting, because what they're basically saying there is because there's no scale in between those lines, you cannot quote it as a half because it was black. It's quite interesting that they've made amendments to that question. They've made amendments based on how it's come out on the diagram, which is very interesting. So you can see my answers. 34 was the reading, volume of oxygen used. And by the way, note my maths, folks. A lot of students dropped this mark because they did the maths in their head and got the wrong answer, which was really silly. Please, emphasizing again, use a calculator even if it's easy maths. Please, please, please. Okay. By the way, just for those people who are wondering whether or not they lost a mark on the volume of oxygen used if they quoted a different number. If you quoted 35, then you were allowed to do the maths and spit out 41 instead. So, or 43, can't remember which way around it is. And that's why you do the maths on a calculator. So anyway, so you just spit out your answer. This question is the first one of any difficulty. And this one, year 11, this one upset me. Because you guys have been learning about the atmosphere for years and years and years. And if I asked any student from year 8 to year 13 how much oxygen is in the air that you'd breathe, they'd spit out 21%. This is a good thing to know, because it means if you get a question where they're wanting you to work out the oxygen in the air, it knows you roughly know what the ballpark figure is going to be. Some people were spitting out 60%, and I think somebody spat out 1%. And I was thinking, well, if it was 1%, we'd all be dead. And so please, please, it's nice to know those numbers just because it puts you in a ballpark area. And the tricky bit of this was to realize that they had a load of volumes here that no one really understood how to use. You had to work out the total volume in the entire system. That included the conical flask, the connecting tube, and the gas syringe. So you can see that I have added them all together here. I added them to get a total vol. That there is the total vol in the entire experimental setup. I then needed to work out how much oxygen, what volume changed. And that, of course, came from the syringe readings. So I then followed that with 80 minus 43 to give me 37. 37 was the volume of the oxygen that must have been taken out of the system by the reaction. So 37 over the total volume of 190 times 100, and I got 19.47, which rounds to 19.5%. Just a reminder, in all of your GCSE exams, all of your numbers should be quoted to 3 sig fig unless stated otherwise. Do make sure that's done. How many decimal places do you have to do it in? Totally get it. And the answer is, in this case, 1, because it's never about decimal places. It's about significant figures. So my 19.47, that's 4 sig fig, and I'm going to round it to 3 sig fig, making it 19.5. By the way, on the mark scheme, it did allow 19.47. So, which frustrates me because it means that they're not being consistent. I would always say, give every single value to 3 sig fig. What that means is, just to tell you, by the way, that's an interesting thing that I've just said, because actually I should therefore do that. Because if I'm going to quote all my numbers that I want them to look at to 3 sig fig, then 37 should be 37.0. But it's really picky at that point. It's the answer that you're quoting at the end. Any numbers you want them to mark, please make sure 3 sig fig. Next one, this question was has thrown a whole load of people off. This one, I'd probably say is the percentage of oxygen in the air was poorly marked across the year group. I'm suddenly realizing I can show you that I need to be careful here because I don't want to show names on the data. I'm tempted. I can probably, no, I can't do that actually. I'll show you the data another time. I don't know how I'd pause the video. I'll just keep going. But that question for oxygen was hard. People really struggled. The next one, the wet iron filings not in excess. What would happen to the volume of oxygen? Oh, one of the questions I did to 3 sig figs and I got it wrong. Oh, Dana, which question was this? Might be good for you. If you can track down that question, that'd be useful. I wonder whether or not it was because you wrote down the wrong numbers. Sorry, I shouldn't laugh. Okay, the wet iron filings not in excess. If they're not in excess, there won't be enough iron to remove all the oxygen. So it would decrease the amount of oxygen used. So if you put in less, you're going to remove less oxygen. And our syringe value wouldn't have dropped as much as it did, so it would decrease. The apparatus was left for 1 hour instead of 1 week. Right, it takes a week. This process of rusting takes a long time, and a week is a very reasonable amount of time for us to remove all the oxygen from the system. 1 hour, definitely not. What that means is 1 hour is going to decrease the amount of oxygen that we've removed. The apparatus was left in a warmer place for 1 week. Well, if we have to make an assumption here because they're telling us that in a week we saw 19.5%. Well, you could argue this and say, well, I know there's 21% in the air, and if I've left it in a warmer place for 1 week, then I should get a larger amount. But what they're trying to say is that a warmer place, they're not even saying a hotter, it's just warmer. And considering the time length there, the answer they wanted was no effect. If they'd made it, I don't know how they'd change that question to make it clear, to make that an increased value. We have to make a massive assumption that all the oxygen had been used and that 19.5 was the correct number. So, and I think after a week, you probably would. Let's go on to the next one. All right, next one, pretty straightforward. State why the balance readings have negative values. So, okay, CO2 is being lost. In the diagram, we saw cotton wool, hydrochloric acid, malachite chips, malachite making an appearance, copper carbonate, our nice green rocks. And look, in the equation, they've given you the equation, and you can see the carbon dioxide as a gas. And of course, that's going to go through the cotton wool. Now, the cotton wool is there to prevent the loss of water vapor. The water vapor will, of course, be escapable because you can notice that the water is coming off as a gas. That's also, you can also quote that as escaping, but the cotton wool's there to try and prevent the loss of the water. The water will condense onto the cotton wool and remain, so the weight won't lose because of that. They wanted you to say that the carbon dioxide was going to be carbon dioxide being lost through the cotton wool. Mass is lost to atmosphere, so the reading on the scale will decrease. Next, we got given a graph. And they asked, the circle point indicates an anomalous result. Suggest one mistake the students could have made to produce this result. Right, this was quite a nice question, actually, because you had to realize that the anomaly was high. You had to realize that the anomaly was not, it wasn't on the line, it wasn't below it, it was above it. So I have lost more CO2 than what I expected, or I lost a large amount of mass. So number one was, well, they could have added a concentration of acid, which was higher than expected. And because we're having to make dilutions, that's a very reasonable suggestion. Dilutions are tricky at the best of times. Oh, Dana said it. Dana said, paper 2, I did it to 3 sig figs, but I lost the mark because I didn't do it to 2 decimal places. Dana, I bet the question actually said, though, 2 decimal places, didn't it? That'll be in the question, but that's on paper 2. We'll do that tomorrow. So you had to say, you weren't allowed to simply say the concentration was wrong. You had to say the concentration was higher than expected. You could have also said, the surface area of the chips was greater than expected. You were allowed to say that water could have escaped from the cotton wool. There were loads of little answers that they could have given. If the question says suggest one reason and you give more than one, would you be penalized? I love that question. Give one reason. Right. Okay. Who asked that question? Who asked? Who was it? Penalized. Was that is that E Kim? I think it's E Kim asking that question. The live streams are recorded. Yes, they are. Okay. So if they say to you, give one answer, and you write 5, they will mark the first one and stop reading. It's a lovely thing that people, I don't know why people haven't been told this, but if you write 2 answers, they mark the first one and stop. That's it. Oh, it's Kayun. Oh, yeah, okay. That's funny. Yeah, okay. So anyway, so they mark the first one. That's it, and stop. State the relationship right. First one where a lot of people dropped this mark. A huge percentage, probably in about 50–60% students lost this one, which is this is a straight line through the origin, right through. What that means is there's only one relationship that you quote, and that is directly proportional. I know that's frustrating. Lots of people put a positive correlation. Lots of people even quoted data. As you double one, you double the other. You have to use the words, which is really stupid, I know. Directly proportional. Right? Explain why an increase in the concentration of the acid causes an increase in the rate of reaction. You should use particle theory. Right? Anybody who has me as a teacher knows my method of kick-ass. I have done this is a 2-mark question, and I've got to give everything. And in fact, it's nice for me to just walk you through this. The first K in this setup, you can see I've crossed it out. The K stands for knowledge. You have to state what concentration is. More particles per unit space. You must use those words. Particle theory requires it. Then the next one, the C stands for collision frequency. Now, lots of you have lost this mark because you missed C and went straight to S. Lots of students think that more successful collisions is a mark, and in this case, it's not. The reason why is because there are lots of things that will result in more successful collisions. But in this case, the reason for that increase is due to an increase in collision frequency, or the number of collisions. Lots of students got 1 mark. They got the first bit, more particles per unit space, but then followed it up with, therefore, more successful collisions. And that's not enough. You have to say there will be a higher collision frequency. So if it was the opposite, would you say inverse proportion, or as one increases, the other decreases? I missed this question entirely. What in KCAS asked for question C. Okay, for question C, I got 0 marks, but I said concentration increases, the number of particles increases. Right, that's not allowed. Knowledge collision does. Thanks very much, Yi. You're doing a great job there, filling in there on the chat. That's great. Collide more frequent. Yeah, you can say that they collide more frequent. Yeah, that's okay. That's allowed. Right. To answer the first one, if it was going in the opposite direction, you'd say it was a negative correlation. And of course, the reason why the directly proportional vanishes is because you're not going through origin. So then I would say it had a negative correlation, and I would quote from the graph the data. Lots of people struggled with this question just because they weren't saying the right words. Do watch out. You can't say more particles, because that's the same as adding more, but that doesn't increase the rate. Concentration, it must be more particles per unit space. And you cannot skip the process. Collision frequency. A, by the way, stands for activation energy. You can see I've not written anything because the temperature hadn't changed, so I ignore it. 2 marks for the top 2. The third one, my last bullet point there, this bit here is not a mark, but I write it anyway because it's good practice. The top 2 are where your marks are. Next. Okay, we're doing really well. Question 8. Oh, this was really horrible. I'd never seen this By the way, I actually, as a consequence of this paper, I attempted this practical. It doesn't work very well, but it does kind of work if you stopper the thing with some cotton wool. So what's happening here is they've given you an equation. Now, guys, if they ever give you an equation, the answer is in the equation. They gave everything there. So the first thing they said is they put some ammonium chloride solid in the bottom of the test tube, and they're going to heat it. And then, so if you heat it, it's going to go through thermal decomposition, and it's going, I mean, he mentioned frequency. Solid X was cotton wool. Ha ha ha. Yeah, I know. There are some hilarious answers going on for this question. Honest to God, it was brilliant. I had somebody wrote the gases in region Y was air. It was all very entertaining, guys. But they're going to heat up the solid. It is going to break apart. There's the solid. If I heat this, it goes that way. Heat. And I'm going to break it into its two gases. And you had to simply name the gases. Now, this, of course, has problems straight off as well. Almost everyone got ammonia. That one people got. But then everybody called this one hydrochloric acid. And it's not. Hydrochloric acid is when it's aqueous. That there is hydrogen chloride gas. And it said specifically on the mark scheme, do not allow hydrochloric acid. That was tough, that.
That's where HCl is.
It is. HCl is hydrochloric acid as long as it's in water. HCl is a gas, and you guys never get to see it as a gas. You see it dissolved in water, and so it's an acid. Acids are, you can't have an acid without water. That is true. If there is no water, I am not an acid. You have to be added because it depends if it's aqueous or gas. Yes. So that one was clever. And so that one was Edexcel desperately trying to make something where everyone's going to name it badly. They've deliberately done that. That's a trap. So the ammonium chloride gases, ammonia and hydrogen chloride. What's change of states occurring? I love the subliming appearing in that question. I thought that was really nice. So the solid just instantly transfers into a gas. It breaks apart and sublimes. Next. Right. Now this one was interesting because this is the normal questions year 11. This is the question I always expect. You should have seen this many times, this demonstration. You should have seen this in year 7, should have seen it in year 8, should have seen it in year 9, should have seen this year on year. What is the difference between subliming and evaporating? An awful lot. Flippin' heck. Subliming is when you go from a solid straight to a gas. You skip the liquid phase. Evaporating, by the way, Lucas, please delete evaporating. The reason being is the only time you say the word evaporation is during the crystallization process, when you're getting salts out of solutions. But for the state change, it's always boiling. Evaporating happens all the time. Boiling happens at its boiling point. Isn't evaporation liquid to gas, but subliming is solid to gas? Yes, that's correct. But evaporation is liquid to gas below its boiling point. Please, please, please steer clear of it. Evaporation is when it's not at boiling point. Yeah. Okay, so this question appeared. This is the normal, this is this tube. If you have never seen this, year 11s, if you've never seen this demo, and I don't know how that would have happened, but it's possible. 11s, I don't think I showed you this even last year. I show it to my year 9s. So if you've not seen this, I will set this up and I will show you the demo. This is just a big long tube. I've added concentrated hydrochloric acid, concentrated ammonia on the other side, and you form a ring of white smoke at point C. It's not in the middle. My 11s, I apologize. A lot of my 11s, over half, have gone for B. And they've then, of course, the problem is this is a 3-mark question, which is a nightmare, because if you choose the wrong location, You're going to try and explain it, and you're going to lose all three. That's mean. That means if you get one thing wrong, you lose the lot of them. That's tough, that. The answer is C, and the reason being is ammonia has an MR of 17. Hydrogen chloride gas has an MR of 36.5. HCl is heavier, so it will diffuse more slowly. But here's the crucial third mark. Travel less distance in the time. Loads of people missed that third mark, folks, because they didn't mention distance traveled in time. That one there was a nightmare. Lots of students had the right idea. They'd quoted MRs. They'd get told, they'd said diffusion happens more slowly, but the diffusion happening more slowly is not the mark. The marks are for C's position. The mark is for the MRs being different and traveled less distance in the time. That's what the 3 marks were for, not for diffusing more slowly. It's tricky, that.
Lucas said...
What if I said ammonia is lighter?
No,
ammonia is lighter. Did you do a direct comparison, Luke? Who's written that? I think Kaon's done that, hasn't she? Ammonia is lighter. Lucas, I said travels less before they meet and react to form ammonium chloride, but I didn't get a mark. It travels less. Travels less. I'm really tempted, Lucas, to give you a bonus, to give you that mark there. And the answer is, I probably weighed it up quite carefully. It was travels less distance in the time. They wanted a time thing, but it would have been a very close call, that. This is what I mean by making sure that you write down exactly what the markers want you to say, which is really tough, I know. What about in the same time ammonia traveled further? Yes, that's okay. That's allowed. Yes, Tiffany, absolutely. Did I not give it to you for that? Intrigued. Right, let's keep going. Next. Well done, Year 11. You did really well on this one. I was really, really pleased with this, which was zinc and hydrochloric acid, salt formed, zinc chloride. It was well answered. Other products, hydrogen. And lots of people, I saw MASH appearing on a whole load of papers, which I really loved. Metal plus acid goes to salt and hydrogen. Calcium carbonate and nitric acid, calcium nitrate. This was the only one where people made mistakes. Lots of people put carbon dioxide and forgot the water. Easy mistake. Make sure you're quoting, because there's the little S. It says name other product or products. That was a hint to there's more than one in one of these boxes. Thought that was clever. Next. Right, so they were doing a process of making a salt. They wanted to make aluminium sulfate. He then had this method. It said state 2 ways to make sure that the acid is completely reacted in step 2. Use excess aluminium hydroxide. Number 1, top answer. I hate this answer. Stir thoroughly. I hated it, folks. I wrote it down, funnily enough, without looking at the mark scheme. I was like, I'd probably say stir it, but that's because this is really tricky. There were a few other answers on the mark scheme, but the problem was every single one of them was really, really horrible in what you had to say. Because a lot of people were like, oh, keep the reaction going until all the solid disappears. Well, guys, that is wrong, because if all the solid vanishes, then you never had enough to use all the acid. It means that the acid must have been in excess for all of it to disappear. So you couldn't use that one. Lots of people were like, heat it for 20 minutes, heat it for a prolonged period of time. Really tricky, that, because the problem is they didn't give an idea of how long they were heating it for in the question. And so I was tempted, and I'll check back on the mark scheme for heat for prolonged time, but I'm pretty sure they didn't allow it. It was really frustrating. There was another one. Place a glass rod in size. No, you can't. I like what you were doing there, though. You're looking to see, the reason why that wouldn't work is because the glass rod is used when you've reached saturation point. You're not at saturation here. You're making a salt in a solution which is in a large volume of water. your glass rod trick you've taken right out of the making salts part of this topic. I do understand why you're adding it. I really do. I get it, but it's not one that's in the correct place.
What if you just put it in and left it?
What if you just put it in and left it? It was this ways to make sure it's that bit, isn't it? That all the acid is reacted in step 2. Lots of students said test it with indicator. That was allowed on the mark scheme, but it had a clause on it. You had to say take out a sample and test pH. That's what you had to say. Remove a sample, which I thought was rather interesting. So they're allowing you to do a test for it, even though really it doesn't really ensure that it's all reacted, because what would happen there is you'd realize that it would go red and you'd have to do the process again. So testing it doesn't actually ensure it's all used. It just means you know if it has or not. Edexcel is harsh. Yes, Edexcel is pretty harsh on those kind of questions. They seem to be tough. So anyway, state the purpose of filtration in step 3. It is to remove the excess aluminium hydroxide. They actually allow, this one, Edexcel were nice on, which was, they allowed you just to say, to remove the solid. Yeah, and that's all they need to say. But the idea of it being the aluminium hydroxide being in excess was, in my opinion, I think it's important and it's good chemistry. But they did just simply allow to remove the solid. But what they didn't allow, and this is important, it said do not allow to remove impurities. That was not allowed, because that's not the purpose of the step. They've added loads of aluminium hydroxide. Filtration ain't going to remove your impurities. What are people eating whilst doing the webinar? Is that what the chat's about? Going out for dinner. I like it. We've got a whole chat going on. Next, state one of the method. Oh, guys, this question by a mile was the funniest question on the paper. So you've made some crystals, you've got them out, you've filtered them out the beaker, they're on wet filter paper, and it says, how do you dry them? And loads of people have just put some brilliantly funny answers. Use a hairdryer. Who would use a hairdryer? Guys, just imagine doing this. I've got a white powder, white crystals, which are wet, and I'm going to stick a hairdryer on. It's going to blow them away. Somebody said, leave them outside in the sun. What was really funny was, it has said on the mark scheme, allow, leave in sun. And it then said, do not allow, leave outside in the sun. The reason being is if you just left it outside, you'd come back and it would be gone. It would just blow away in the wind. So they needed you. And what the answer is a drying oven. It's said on the mark scheme, and Lucas, this comes back to your Edexcel being harsh. The top answer, our survey said, is a drying oven. But it said, do not allow, put in oven. You had to say, I know that's really stupid, this. The reason that what they're trying to say is that there's a difference in equipment. Edexcel is whack. I like it. They're trying to get you to realize that a drying oven for salts is not the same as an oven you'd use at home. If you put it into an oven at home, you'll probably melt them and set fire to the paper. A drying oven in a chemistry lab only goes up to around about 75 degrees Celsius. You can't go above that. So it is a different piece of equipment, and that's interesting that they said do not allow oven, but the top answer was a drying oven. Next, right, first calculation of the paper. Students found this really tough. Everyone seems to have guessed the right answer, even without showing they're working. And you can see where the numbers, oh, do you know what, guys, this actually has just brought to my mind. I really, really need your help here, 11s. Right, lots and lots of you are doing good chemistry maths. However, what you're not doing is showing me the total number. Please, please, you cannot leave it as just the maths maths without the number. You need the mark is not for this, it is for that number there. And I think I've been overly generous here with these marks. I've given a whole load of calculation marks because you're doing good numbers, but I need to emphasize year 11. Please, please, please show the end of these calculations. Please, it's important. Next, once you got the MR of aluminium hydroxide, there was 1 mark, 78. You then did 3.9 grams over rams to give you moles. You had to comment on the ratio, although show absolutely nothing with it, which I thought was brilliant. But you had to show it. You should always show it. But then the 3rd mark was for that guy, for showing that 0.09 is greater than 0.05. And you were done. So sulfuric acid was my answer. Said baking.
In an oven.
Yeah, that's it. Oven doesn't work. Oven, yeah, you're not allowed to use the word, you have to say drying oven. A drying oven is not the same as a baking oven. That's the difference for that question. Anyway, back to the maths. Next, another student prepared 0.25 moles of aluminium sulfate. The formula is this: calculate the mass he prepared. So guys, again, exactly the same process. Make sure you're, look at what I've done. That's the mark, but you need that bit. You need the final number. Don't skip it.
That's the right answer.
What's the right answer? For which one? He laughed at the answer in our chemistry session thing. Nah, the hairdryer one was my favorite one. So what was the right answer? In a drying oven. Oh, use a paper towel. They allowed that. That was brilliant. Paper towel is allowed, even though you'd lose half of it by patting it. Half of it would stick to the paper and it would disappear. But they did allow you to say to dry using a piece of paper towel. They did allow that. You can't say that apparently. No, you can say paper towel. They allowed it. Back to this calculation. MR 342 grams over rams, but you had to reorganize. You can see my whole reorganization process. I quoted grams over rams, reorganized moles times rams gives me grams, run it through, and I got my right answer in grams. Next. Moles. Okay, same thing.
Oh, hang on. Oh, miss all day.
Took 1 mark off because I didn't rearrange the formula. Is that 1 mark on the mark scheme? Yes, it is. You need to show it because that's a 3-mark question. Now, okay, technically, see, you can see my process. I've started at my originals and I've shown my rearrangement. Technically, if you have shown that there, if you've shown the calculation itself with all the numbers correct in it, you can have 1 mark back for your rearrangement because that technically, but if you have not shown your working out and you've just spat out the answer, you'll lose that because you haven't shown your rearrangement. But note what I'm doing. I'm answering this as I just want to gain everything. I want to make sure they know what I'm doing. So I've shown every step of that because I don't know where the marks are coming from. Always do that. Okay, next, going back up. Oh, there we go, back. Okay, so in the second experiment, you can see I've written the ratio on top this time. 1, 2, 1, 1. In one experiment, the amount of lead oxide used was 0.75 moles. The amount of nitric acid used was 1.5. Now, that's really clever because if you notice, that's neat. It's a trick, this, because if you actually write in those numbers where they should be, 0.75 moles of that and 1.5 moles of that. Note the ratio. The nitric acid is 2 to 1, and they've put in double the number of moles. What that means is you can use either one of those numbers to get that number, which is really funny. You've just got to remember that that one needs to be divided by 2, but it gives you 0.75. I love the fact that we're having this big conversation about everyone saying, I'm hungry. Bring me your Big Mac food. You watch this at the dinner table. That's so funny. You guys make me laugh. Anyway, so 0.75. There's my moles. 0.75 moles of potassium. Lead nitrate. I had to work out. Oh, they gave me the MR, so I worked out a theoretical yield of 248.3 grams. Then I did 209 over the theoretical. So what I got over the theoretical times 100, I got 84.2%. It was done actually pretty well by you guys. Well done for that.
Do you get working out marks?
Yes, absolutely. Yes, you do. You're going to get the working out mark is that one. If you've then gone mad and started using numbers all over the place, you'll lose most of them. Because the problem is people started throwing numbers all over the place there. Even if you've got the right methods, you'll lose it for the wrong numbers. So I understand what you're asking for there. You're saying, are we getting method marks? But you can't get the method marks if you're using crazy numbers. So that one's a little bit tricky in that sense.
Did we have to times 100?
Of course you have to. Oh, guys, please don't do that. I'm seeing this happen. People are giving me that equation. 209 over 248.3 gives me 84.2%. No, it doesn't. It'll give you 0.842. You must show that times 100. Please make sure you do it.
What, the 3 marks?
The 3 marks for the question is for realizing, therefore realizing 0.7 moles, 0.75 moles from the ratio in the equation. And that those 2 moles there are the same. So you could use either one. You just remember to divide. You get to 0.75. So that there, 1 mark. Oops. Hang on. I don't know. I've just gone and done it. Hang on. 1 mark. 2 marks. 3 marks for final answer. There are your marks. That's them. And then putting it on the line, of course. Lots of people keep forgetting to. Oh, stop it. Lots of people are forgetting to put on the line. Please don't. Next question. Oh my God, Year 11. Easiest question on the whole paper. And I've got half the year group getting it wrong. Relative mass of a proton is 1. Relative mass of a neutron is 1. The electron is 1 over 1836, even though they quote 40. Relative mass of a neutron, relative charge is 0, electron minus 1. Easiest question on the whole paper. I had low, year 11s. Can you explain, Mr. Duncan? I wrote 0.7 for that much, but I didn't get a mark. Oh. Okay, if you've actually said 0.75 moles of lead nitrate like I have, you can have one. If there's any ambiguity, if you've just written down 0.75 moles of somebody, but if I will happily give you that mark if you've made that clear. You can see how I've done it. Moles of lead nitrate. If you've done that, you can have one. Definitely. This whole table was ridiculous. Guys, learn this table, please. It was crazy. By the way, just to say, in your real GCSE, they're going to ask you to fill in that guy. They're going to ask you to fill in the electron mass. You're allowed to quote 1 over 1840. You're allowed to quote 1 over 1836, but I wouldn't recommend it. I'd honestly say write one word, and that word is negligible. That is what that answer is in your GCSE exam. Oh, my tablet's struggling a little bit. Negligible. That's what they want in your real exam. Yeah, they're going to make you do that, but that is going to appear in your real exam. Do watch out. Next, number of protons. They gave you an isotope of hydrogen. They gave to you tritium. This is a hydrogen atom with a mass of 3. Number of protons, 1. Number of neutrons is 2. Number of electrons is 1. Lots of people put the number of neutrons as 3. You know the trap, guys. That top number is protons and neutrons. So one of them is a proton, therefore 2 neutrons. Easy mistake. Don't do it in your real exam. What is meant by an isotope? Guys, this was answered really badly. It really was. And you know what? This is important that I highlight keywords here. And you'll notice I've done it actually in my model answer. Atoms. Lots of students have lost this mark because they've said an atom with the same number of protons and electrons but different number of neutrons. That's not correct. If you've put an atom, you lose everything. It's really, really harsh, this. You have to say atoms with, because isotopes rely on the fact that the atoms are being compared to each other. And if you say an atom, you lose the lot, because if you take a single atom, you can build one with the protons adding to the electrons, adding up to the neutrons. You can all, and with different, you can do that. But isotopes are compared to each other. So you need to say atoms with. For 10 BII, I wrote 2 definitions. Do I get at least 1 mark? How can you write 2 definitions? How can you do that? You're saying that, in fact, you're going to be saying, can I get a mark for saying different numbers of neutrons? That's probably that's the mark that everyone's going to fight for. And I'm going to say it. They even allow different mass numbers as well. I'll probably say I've probably been a little bit harsh on that. I said the same number of protons but different number of neutrons. Do I get a mark? You can't just say that. You have to say atoms with. That you could be talking about an atom there rather than comparing 2 atoms, Dana. That's the problem. You can't have it. It's really all because you have to say atoms with the S on. If you say atom with, you're done. You lose it. Do watch out. That one, and it's going to appear on your paper. I'd say learn that one. Right, next one. We were working out the relative atomic mass of bromine. You can see my calculation. Guys, you had no excuse for this one. No excuse. They gave it to you on a plate. 79 times 50.7. 81 times 49.3. Add them together, divide by 100, and you got 79.99. They literally walked you to that, folks. And a whole load of people, by the way, a whole load of people left it blank. They'd just flat out forgotten and just gone a little bit mad. What if you say atoms of the same element with the same number of protons and electrons but different mass number? Actually, you'll probably get 1 of the marks for saying that. The different mass numbers, they allowed it. That one, and you'd probably gain 1, maybe even 2 for that. Is that Juyi? You probably would. How many marks did I give you for that, Juyi? Interested to know. I'd say I definitely should have given you 1.
One mark for it,
I got 1 mark for it, yes. That's fair enough. You need to be saying different numbers of neutrons. Yeah, it's all about the neutron numbers being different. I put that and got both marks. That's funny. Okay, so there's discrepancy there, definitely. Lucas, lose 1. Take it off. Love it. Anyway, back to this. Calculation. Somebody mentioned something. I don't know who this Akatera is, but anyway. I wrote 81 times 49.3. There was a question mark and a cross. I got 1 mark because the answer, but lost 1. Yeah, you didn't show the rest of the calculation. You can't just show 1 and not the other. You had to show the whole thing. You can't just get halfway through it and then go, oh, I figured it out. I'll just put the answer in. You got to finish it all. Next, nice easy question. Which one was oxygen? 2 shells, 6 in its outer. D, nice and easy. Next, which one was the oxide ion? It could only have been, this question should have been the easiest one on the paper. It can only be A. It's the only one with a 2- charge. All the rest, positive, 2 plus, 1. No, A all day long. You didn't even need to look at the electrons. You just picked it out through the charge. Right, next, first bonding question. Ask you, explain in terms of structure and bonding why magnesium oxide has a high melting point. Students in my class know this method. Susan Boyle sings Nelly the Elephant. Structure, bonds, strength, number, energy. Structure, giant ionic lattice. Bonds are the electrostatic attraction between oppositely charged ions. This attraction is very strong. There are millions of bonds to break, lots of energy needed. Do not skip. Everyone goes, it's 4 marks. Which one don't I need to write? You write all of them. All of it. Don't cheat. You don't know which one they don't want. They probably want all of them anyway. Go the full way. I finally got my full marks on the bonding question. Way well done. There's a better explanation. There's a better expansion of Johan. There isn't. Susan Boyle sings Nelly the Elephant is definitely the only acronym that I know for that. No. Oh. Anyway, moving on swiftly. Anyway, definitely worthwhile practicing those questions. You are gonna get a bonding question.
I like that one.
Yes, I know. Next, name the salt, magnesium chloride, formulae. You knew they're going to do this, guys. MgCl2. Nice and easy. Just people forgetting the 2, of course. Usual thing. Loads of people put just MgCl. We're better than this, year 11. Next one. This is a shout out for Winkit. Winkit absolutely lost 7 marks right here on his paper. Now, guys, this is actually important. I know Winkit's going to be thinking I'm bullying him here, and I definitely am. But actually, it's important for me to make this point, which is, guys, if you choose the wrong bonding type, and they then say, draw your picture, you get it wrong. And Winkit did this as ionic and not covalent. What that meant was it then said, explain how the atoms are held together. And Winkit went into ionic and dropped all of it. It then said, explain why sodium bromide is higher than hydrogen bromide. And it was just, I like it. Hashtag bully Winkit. Thanks, Connor. If you do it, you're going to lose everything. There's no method marks in here. There's no, error carried forward. You will just lose. And that for Winkit was an entire grade boundary. It's actually a grade boundary and a half. What does George says? What's the S? The S. It's a method for being able to give good structured answers for explaining boiling points. So whenever you have explain the high melting point or low melting point, you need to hit certain things, which are you need to tell them what the structure is. So if I was going to do this for HBr, it would be structure is simple covalent. Bonds, covalent bonds within the molecule, weak intermoleculars between the molecules. Strength, weak intermoleculars are very weak. Number, there are very few of these bonds, therefore not much energy needed to break. So it's just a method of building melting point questions that stops people from waffling too much. Okay, so next, once you did your dot and cross diagram showing the overlap, it said, explain how the atoms are held together in a hydrogen bromide molecule. They share a pair of electrons, 1 mark. And the second mark, year 11, and especially going out to my class, none of you got this. Actually, no, I tell a lie. Maybe 1 or 2 did. But the electrostatic attraction between the shared pair of electrons and the nucleuses of each atom. That's hard, that. Explain why sodium bromide has a higher melting point than hydrogen bromide. Sodium bromide is ionic. Hydrogen bromide is simple covalent. Weak intermolecular forces between the HBr molecules is weaker than the electrostatic in sodium bromide. Tricky that, because they didn't give you a lot of space for it. You're absolutely right. I might need to ban Dana. Do you know what, Connor? I'd totally ban her if I knew how to ban her. I'd be all over that. Anyway, so that was a comparative of bonding. The marks there are for the 2 bonding types, ionic and simple covalent, and then the comparisons of the forces and their strengths. Wait, I wrote ionic bonds are stronger than covalent bonds, which is not correct, because you're not breaking covalent bonds. You're breaking the weak intermoleculars between the molecules. You'd lose it. As soon as you said that comparison, you lost those marks. Apparently, Dana, apparently I can report you. I'm not going to do that. I'm too nice. I won't start doing it. Okay, into your empirical formulae. Guys, you just didn't remember how to do it. I do know. And Dana, you bring great value to these webinars, so I'd always keep you. Sodium bromate. So it's giving you the percentages. Guys, you just had to walk through the process. The bit everyone missed was dividing by the smallest. That was the bit that everyone struggled with. Sorry, mean beans. That's really funny. The mean beans. Who is that? Sorry, mean beans. Where's your question? For 3AII, I wrote, they are held together by covalent bonds. Strong electrostatic force of attraction. Do I get any marks? Good question. Hang on a minute. So it said, explain how the atoms are held together. Okay. Annoyingly, you don't, I'm afraid, mean beans. You get nothing. The reason why is that the covalent bond is not enough. You had to say what a covalent bond is. And by the way, I understand why you feel cheated out of that, mean beans. I really do. The reason why I understand is because I get that you feel like you should have got a mark for stating the correct bonding type. I get that, but this one was just they wanted you to go into the covalent bond a lot deeper for the 2 marks, and I do understand why, and I'm sorry about that. Anyway, moving on to the next one. So yeah, by the way, I had some students on the empirical formula one. I had someone who had massive numbers. I had somebody who'd got stuff like this. It was really funny. Like, it was hilarious. Like, somebody had gone crazy and written enormous numbers into their empirical formulae. That is a worrying sign because it means that you don't really know what's going on. The simplest whole number ratio, this should be the smallest version of it, and you just went completely crazy. Do practice these questions. They're going to appear. Empirical will be on your real exam. Definitely one to look over. And again, guys, I am running, and you all know this, I am running GCSE revision classes now every Wednesday lunchtime and Thursday after school for an hour. And come along, I can do some empirical formulae questions. I can do the bonding stuff with you. We can go through all of these things. You can even do a couple of demos or a couple of practicals that if you want to have a look at some. Suggest 2 reasons why platinum is a suitable method for flame test. It's unreactive, top answer, and high melting point. Lots of people said it was strong. No, platinum is not especially strong, actually. It's a bit of a flimsy metal, to be fair. They're sticking it in a flame, and so we needed high melting point and unreactive because it needs to not react with what you're putting on it. Another alternative metal would be gold, another great one. You can't use aluminium; it would melt. Steel would react with it. So gold or platinum are your choices, and we tend to use platinum loops. Next, why should the platinum wire be cleaned between each test? To prevent contamination of the next test, as this would affect the colors seen. You can. I've written a lot there for that 1 mark. The reason being is I really wanted to make sure that I was saying everything that they wanted. I nearly just ended it at to prevent contamination. I nearly stopped there, but then I was like, I don't actually know what they're wanting on the mark scheme, so I need to make sure I get across that I understand that if it's not clean, I'll get a funny color change and I won't know what the substance was. I see a fake Mr. Duncan. Is this a scam? No, there's not a fake. Oh, actually, I think that is there another Toby Duncan? Is that me? Is that you? That's you, isn't it? No, is that a fake Mr. Duncan? Did you write that after Luke? Hi, Luke.
No, that's not me.
Oh, there's a fake Mr. Duncan on this. I don't know what's going on with that. Yes, someone's typing. It's not me, folks. I don't know who that is. That's really funny. Can you do that? Can you just pick a name? Oh, I wonder if, I can totally ban this person, hide this user on the channel. Oh, I can remove them as well. Identity theft. I know, right? Do you know what? It's lucky that I don't mind. They can leave it there. Anyway, next. Why is the luminescent, guys? This luminescent has completely thrown people. The luminescent just meant yellow flame. And of course, you can't carry out a flame test on a yellow flame because all your tests will look yellow. It's called flame masking, and it just means that you can't see it. This identity theft who's stolen my identity is causing total mayhem on the chat. Next one, you can see how I've identified my salts. We're at the end of the paper now, folks. This is the very last question now, so we're nearly done. Compound X. So I looked across X. The yellow flame test gave me sodium. There's Na plus being yellow. There's that one. And the white precipitate with silver nitrate gives me the chloride ion. So sodium chloride spat out there. The next one, red. Red, of course, is lithium 1+. And the white precipitate with barium chloride is a sulfate ion. So that was lithium sulfate in the end. Just nice and easy. Just got to know your tests. Which cation was present in Z? Green precipitate with sodium hydroxide is iron 2+. I said the color would stay orange. Yeah, the person who said that, Tenzi, you're being too vague. Definitely too vague. A couple of people saying it's purge. I said the color would stay orange, but didn't get the mark. Yeah, it's too vague. You need to say that the orange color would cover up the color that you're meant to see, and it would make it difficult to see it. I know the fact that you're saying it stays orange. It's tricky, that one. Yeah, he definitely doesn't get the mark, though. Why doesn't the yellow flame, isn't it a hot knife to vaporize? Of course it is. The yellow flame is 450 degrees Celsius. That'll vaporize some of it. So it will, you can't say it's not hot enough because it is hot enough. Guys, I'm happy to show you a flame test on a yellow flame, and you'll see the flickers of the color coming through. You just see yellow most of the time, but it's still there. Why can't Y be calcium? Because it doesn't, right? Everyone's saying this. Calcium is not red. Calcium is brick red. And if it says red, it means lithium. If it wants calcium, it will say brick red. I wrote the yellow flame makes the actual color of the flame hard to see. The actual color of the flame. Yeah, it was the of the flame, which is a bit weird. The color of the flame test. Yo, I could probably give you one for that. At link here. I don't know. I wouldn't know. Tell me the diff. I don't know who's taken over my name. Someone has genuinely taken over my name. I've never had that happen before. Tell me the difference. Oh, Dana, calcium, brick red, lithium, crimson red. Yes. Brick red is brick red and crimson red is crimson red. Crimson red is super red. It's the red that you see like is the red. It's the red people use for bullfighting. It's very red. Brick red is more of an orangey red. I mean, brick red is a darker red. Yeah, it's not even darker. It's just more orangey. I thought lithium would form a precipitate with sodium. No, none of the group 1s do. The group 1s never do any precipitates. They only come out through flame tests. The precipitate tests with sodium hydroxide are, I like scarlet red. That's funny. I've lost what I was saying now. Yeah, the precipitate tests are, there are very few of them. Copper being a 2+ being blue, iron 2 being green, iron 3 being brown. There aren't many of those precipitate tests. Anyway, next, and the very last one. This is the end of the webinar, folks. Add acid to the sample, then bubble gas through lime water. I've been very generous on this question, folks. Lots of people just wrote add acid as the test. Results fizzing, bubble it through lime water and it turns cloudy, even though that's part of the test bit. But don't worry about that. The mark scheme was actually really generous on that as well. So add acid to sample. That's the test for the carbonate ion. It will fizz, and then bubble that gas through lime water and it will turn cloudy. So that brings us to the end, folks. We're done. It has been, let's see if I can go back to my Google Hangout. You are screen sharing. Stop my screen sharing. And it brings me back. Hey, guys. Thanks very much for hanging around. I know it's taken us an hour and a half. I really, really hope it was useful. Have a lovely rest of your evening. And I will see you all tomorrow. See you, guys.